Righty. Sorry about the delay there. So this is actually yesterday's stream. Making up for that by doing it today. And today's stream is not now. We're going to do that another time. We're going to do that today, and today has been pushed further into the week. I don't know when today is going to be. We'll find out today, but hopefully not too long for that. But for now, you've got yesterday's stream, so let's begin that stream, shall we? I think this is probably going to be a brief one because it's quite late for me. I am looking at pull requests again. So let's have a little look. So I think last time we were getting about to the Pop 3 input. I really want to get to Jeremy's Nats one because that's big. It's got lots of cool stuff in it. This is also pretty cool, the new Pop 3 input that Marco's been doing. I think this is the last one I needed to look at. If you've authored one of the pull requests that's earlier than this, I will go back to it. It's just I'm trying to get one pass through all of the currently open pull requests, and then I'll loop back around again, since we've already done a lot of those ones. Otherwise I'll just be stuck there forever. So yeah, let's do this one first, and then maybe we'll get onto the Nats one afterwards. As far as I'm aware, there is literally nobody here today yet. I'll try and give more notice for the next one for people who are watching this async. Oh man! Oh, I didn't get to see it live. Oh, shut up. So this is a pull request I already looked at briefly, but it has been updated. So we've got a new package within import, which is mail. So I'm going to go ahead and guess that this is going to grow to become all of our email related connectors. And this is going to start us off with an input that's Pop 3. This is already looking super neat. I should imagine there's not going to be an awful lot left on this one. Let me zoom this in a little bit so it's clearer for people. Right, so summary: connects to a Pop3 server and periodically reads the emails. Reads emails. The emails are permanently deleted when delivered. Might add some clarification on that, because somebody might think that means they get deleted when we've read them, so when they've been delivered to Benthos. But I'm assuming this actually means when they've been delivered downstream to whatever Benthos is connected to. We've got a load of metadata. That's cool. I would maybe be tempted to rename these so that they're more in line with the other connectors we've got that add metadata. And then we've got a bunch of config fields. So we've got a host, we've got a port, username, password. Has this been marked as experimental? Yeah, okay, so this is an experimental component to begin with. I think that's fair, given this is new territory for Benthos, doing anything related to emails. We've got the TLS fields. Okay, yeah, I remember a conversation around this earlier where we were looking at the client library being used. So we've got TLS fields, but we've actually only got two of the typical Benthos fields, which is whether it's enabled and whether we're skipping certificate verification. Not the full suite of TLS client configs that we have in other components. That's a limitation of the client library that this uses, which I think basically I'm I'm okay with this as a beginner. The client library looked like it was very, very simple. I'm not going to dig into that today. So if we ever wanted to expand the options that we've got, we could just, copy paste it, send my T code, I think. So we could just adapt it if we needed to, unless they want to take an upstream PR from us for more TLS goodies. And then we've got the normal stuff, like we've got timeout, we've got the interval for how often we pull. So this count one is interesting. So an optional number of pulls to fetch. If set above 0, the specified number of pulls is executed and then the input will shut down. That's quite interesting. There's not really any reason why we couldn't add that concept to all the Benthos inputs, not just this one. This could be replaced, so you could not have this parameter, instead do the same thing within a read until input by wrapping it. Not sure how. Go with that PR. I'm just going to add this as a note here because it's not going to block the PR, but the horror. If you're gonna miss one, this is the one to miss. So if you've managed to make it to this stream live, then congrats. But if you were gonna miss one, this is probably the one. So if it's the only one you've managed to get to, well, fuck you. Get wrecked. Right, so we've got interval, that makes sense, because we don't want to do a busy loop pulling the server. Timeout parameter, that's fine. Max in flight, max body size, the maximum number of bytes when reading the message body. That's interesting. And list page size, the maximum number of emails returned by the POT3 server. This limit may be configured on the server or may be imposed by the server software. Does that mean it has to match? Why am I asking the stream? I'm just going to add a comment. Okay, and then we register the input. Within our thing here, we've got a POP3 client. We store the username and password, account, interval, basically all the config parameters. We have a message chan, which is this envelope type. We've got a Benthos message and also an ID. I'm assuming that's to associate back to the server when we do message deletes. We've got an ACK chan and a done chan. I'll be interested to see why this needs to be channels. And then we've got only ones which I've already looked at. That's for the connection. So create a new client in the constructor, which has the TLS host port and all that stuff in it. Don't do anything asynchronously here yet. During a connect, we only once instigate this poller. Which then asynchronously fetches emails. Right, this is interesting. So we spawn a go routine. It's got a ticker which matches the interval that we're going to be polling at. And then we have a for loop. So each tick of our ticker. So this is going to block until the ticker has resolved. So if that's in minutes, then this is going to block for minutes, even if the service is shutting down. We'd probably need to break this out and include shutdown signal as well. And then for each message, no, sorry, if we have messages, wait, what? Has messages starts off as true, and then we fetch emails. And then did we get any? Right, so did we... okay, so every interval we essentially drain the server of all the messages that haven't been read yet. And then once that's done, we exit this loop. Or, in the event of the number of messages we got is greater than or equal to the page size, and then that counts for the number of times we run. Okay, so I guess that's why you wouldn't want to wrap it within a read until, because what we're counting here is the number of times we've flushed the server of all emails, as opposed to the discrete number of messages that we've actually consumed from the server. And then, yeah, if we have exhausted the number of runs we're expecting to do, we stop and close, and then that triggers the send over a done channel. So this whole block here, I would probably simplify this quite a bit, because it's doing quite a lot of stuff. And I don't think this needs to be as complicated as it is. It's kind of cryptic. I'll deal with fetch emails in a second. The read is quite simple, so we just read over a message channel, which I'm guessing this fetch emails thing is pushing things down into, and then we've got an acknowledgement channel. Or if our done channel is written to, that means we've shut down and it's the end of the input. Yeah, this is missing quite a lot of stuff. So all of these channel reads need to be protected by context is done. And also the ACK here, that needs to be protected by context is done, just so we don't block forever. This could just be a channel close rather than actually reading a message, because this is put within a... I'm just going to add these as comments. The thing is, this is kind of difficult because these are all like kind of review comments, but I think the real solution is to kind of refactor this slightly, which I think I might actually just do while I merge it rather than asking Marco to do it. Because basically it's just a style difference. Instead of writing over channels, do everything within the read. I'm going to finish reading this first. So the fetch emails call, we establish a new connection, which is interesting. Each time we fetch, we get a new connection. And then at the end, we quit. I'm guessing this is because POP3 doesn't like long-lived connections, which is fair enough. I mean, this is the email world. This isn't this isn't real-time streaming anymore. And then we do our authentication on that connection. Right, which is effectively a login. I get that. And then we list a bunch of stuff. We try and get messages, and then for each message we... Is that a retry? Does that mean retry? We get something back, and then we create a body. So we read everything into a buffer. I'm sure that can't be necessary, surely. I wonder why that has to be fully allocated first. It might just be an optimization. And then we create our message, and then for every header we set all our metadata. Entity.header.map. So I'm assuming that needs to relate directly with the metadata keys we've added here. So rather than just setting these directly, match the style of keys from other inputs. So it'd be, what's an example? So it's the input name underscore, and then let's use an example that has the dashes in it, because basically all of our current inputs have everything's lowercase, and also we use underscores. Is that right? Yeah. Okay, so finally what happens is we send a message down the message channel, and then we run a go routine that waits. Okay, this is a little bit dodgy as well. Basically what we do is we send, so we're claiming ownership of the message channel. This fetch emails call is going to get called within this go routine here. So this go routine effectively owns the channel, which is fine. But then what's happening is when we've called fetch and we walk through all the messages that we get from this list call, we push all the messages down that message channel, which is fine. And then we spawn a go routine that waits for all the acts to come back before we do it again. I suppose we have to do that because we have to make sure that the connection's held open. And at the end of the defer, that's no longer the case, so... I mean, this is only a wait group of size 1, right? Oh, this is very confusing. I have no idea what's going on here. So for each message, we create the message, push to the message channel. Then we create this new channel, act. So we've got a channel called act. And what's that used for? Yeah, I think this needs a bit of a refactor because this is kind of difficult to get your head around. I think this could be a lot simpler. At least I hope it could be a lot simpler. We do need to keep the connection open whilst we're processing those data. Can you imagine we read like 5 messages, 5 emails, send them all down the pipeline. They could take any length of time to reach their destination, and it's not until they reach their destination that we are able to delete them. And therefore, we have to know that the connection is still open, logged in, and all the rest of it, in order to do the delete. But yeah, this mechanism is a bit... I think it might be a bit too much. I think I might have a go at refactoring this. The only problem is, if I do refactor this, the other thing is there aren't any integration tests. So I could make changes to this and have no idea whether they work or not, which is a big problem. Right, I'm just going to give an overall comment of pretty sure we're all good in terms of behaviour, but left a few comments around config options. Also not sure I like the number of channels being used here. It's making it difficult to understand how everything's working together, which is a bit risky, since that also seems to be an important factor in how the due to the connection being short-lived. Connections lifetime being tied to a single flush of data. I'd like to have a go at reworking this to maybe use more synchronous calls within the read method. However, that's also Alright, stick some comments down. I think that'll give enough feedback for now. But yeah, I think basically I would just try, I mean, easier said than done, right? Try and adapt that so that it's more of it essentially gets made into synchronous calls. Definitely the timing bit could be made synchronous within that read. Basically, you just don't trigger a fetch until it's happened, but then you do the fetch as soon as the call to read has been made. And then your connection has to be long-lived. You keep a reference to all the messages that you acquired within the connection. Yeah, it's got to be asynchronous because that connection has to live quite a long time. Ooh. Yeah, that's a doozy, Marco. That's a doozy. Yeah, I can definitely imagine that that complexity is just going to be necessary. In which case, I can just do a bit of tidy up on the channel stuff. Basically, we have to use all the context and stuff. Is pretty much the main thing I'm concerned about, and also some of the done channels being used around that. Ideally, we want to tidy that up. Right, so here we go. This is the next one on the list. I've been meaning to do this for about a month. Because there's a bunch of cool Nat stuff. So we've got Jeremy coming in here. He's got his own Twitch stream. If you want to go check that out, don't check it out. You're fine here. You're fine here. But maybe outside of watching this stream, you might want to go check out his stream. It's on Twitch though. Ugh. That's where all the zoomers are. Right, so this looks like quite a lot of changes, but actually it's quite manageable. So we've updated the input. So this is kind of like an interesting one. Jeremy has chosen to add a default URL to the URLs field. That's actually how a lot of Benthos components used to work. It used to be that when you had like a Kafka input, for example, if you just didn't specify an address, then it would default to looking for brokers at the default Kafka port 6379 at localhost, and that just meant that if you were running containers and stuff locally and you want to do some quick integration tests, then you just didn't have to write it out. I actually went through all of those components a couple major versions ago and eliminated all of those because it was actually causing quite a lot of problems. Because when you specified a default, it kind of masks a lot of configuration errors people might have, and then they would have their services try and connect to a localhost service and fail. And if the error messages coming back aren't particularly good, then you might be running a config that doesn't have any URL specified, and you would have no idea. So I think actually I would probably get rid of these. I know it's kind of convenient, but I think it's worth forcing that to be explicitly specified. I'll add a little comment for Jeremy. This is Is it even worth it? So with stuff like this, normally I would just make the change as I merge it, because it's only going to take me like 2 seconds to do it. It's going to take me just as long to change this. Yeah, I'll tell you what. I'm just going to have to comment, and then if it turns out this is the only thing that needs changing, then I'll go back and I'll delete these comments. This is right, so I'm going to start a review. Right, so we've got a KV input. So from what I understand, NATS now supports key value stores. Jeremy did say during the stream that he added these default URLs because that's how their CLI tooling behaves, but I think Benthos is a different beast. Yeah, that makes sense. Yeah, so I think in the context of CLI stuff, I 100% agree that default URL is fine and very useful. Because obviously in a CLI context, you want to write short and sweet, whereas with a config, it becomes kind of dangerous. Defaults end up becoming a bit of a dangerous thing, because writing a config itself is quite a complex thing, and maintaining it becomes a bit of a complex thing. I definitely think in CLI world it makes sense. I mean, I used to think it made sense in the Benthos world because obviously I did it. But yeah, I think, to be honest, I think it's probably fine either way. But to make it consistent with other stuff, I think it's probably better not to have it. But yeah, so NATS has key values, basically replaces stuff like your Redises, your memcached, all that stuff. I haven't actually looked at the way it works in detail, actually. Tell you what, that might be kind of interesting. NATS key value. Because it'd be interesting to know if this is dispatched or not, or whether it's in memory. Oh, it's built on top of Jetstream. Huh. As the key value store is built on top of the Jetstream persistence layer, you open a key value manager object from your Jetstream context. Get a list of all the keys currently having a value associated using keys. History for a key. Oh, you can get a history for a key. Oh yeah, because it's a log. Makes sense. Yes. Cool, okay. So yeah, that will be persisted. Cool. So that kind of means we're consuming just Jetstream, I would imagine. But it'll be nicely abstracted, I'm guessing. So watch this for updates in a NATS key value bucket. We've got a bunch of yummy, juicy metadata fields. I like that. I might, so the way that Marco's done, very neatly done, solve that. Very neatly done the metadata, the field name thing here. He's got them all as consts at the top of the file. I actually really like that. I think that's a very nice way of doing things, so I might start recommending, rather than just telling people to do it, I'll just start doing it in all the internal components, so when people use them as inspiration, they'll see it. But otherwise, I mean, everything else just uses string literals. So we've got the URLs, we've got bucket, so the name of the KV bucket to watch for updates. Key to watch for updates can include wildcards. That's interesting. So I wonder what bucket is in this. context. Let's have a look. Gesturing the persistent layer of LAS doesn't just allow for higher qualities of service and features associated with streaming, but it also enables some functionalities not found in messaging systems. One such feature is the key value store functionality, which allows client applications to create buckets and use them as immediately consistent, persistent, associative arrays. You can use KV buckets to perform the typical operations you expect from an immediately consistent key value store. Associate a value with a key. Retrieve the value associated with key, delete, clear any value associated. Right, so that's why it's different to just a jet stream. Stream. Can't remember what it's called. Purge, clear all the values associated with all keys. Create, associate the value with the key only if there is currently no value associated with the key. It's basically an add, which is cool. Update, compare and set the value for a key. Keys, get a copy of all the keys. You can set limits for your buckets. Maximum size of the bucket, maximum size for any single value. TTL, how long the store will keep values for. Yeah, it's cool that you can just get the full history of everything. That's just cool. So a bucket is basically a bunch of keys, and yeah, I'm guessing that the main reason why they have that as a concept is because it's useful to have separate separate world of keys, so that you're probably for performance, I'm guessing. Right, so then you specify the key that you're interested in, which supports wildcards. Ignore deletes. Do not send delete markers as messages, and that's false by default, which I think is fair. That makes sense. So here the key has a default. I think that's probably fine. So the bucket doesn't have a default, and I think that's important because we don't just want to assume what the bucket's called. That wouldn't really make any sense. But the key having a default seems fair because we would basically be looking for everything here. I think they're greater than is, I think that just means everything. So yeah, I think that's probably fine. Ignore deletes, include history, include all history per key, not just the last one. So you basically do a backfill. Meta only, retrieve only the metadata of the entry. That's interesting. And then we've got TLS and auth, which is standard for all the Nats components. Cool. We don't have a concept of a negative acknowledgement, so we auto retry on the case of a reject. That's good, that makes sense. Now this is cheeky. You cheeky bastard. He's instantiating a reader and then he ignores the error because he knows that auto retry nags. It doesn't matter if it's nil. Or does it? I'm going to verify that. Trust but verify. I should probably know that. We'll look for public. Nope. Input, auto retry. I guess it doesn't matter if it's null, because connect and read won't get called. You cheeky, cheeky bastard. So what we've got in here is all the stuff that we need to make a connection. Got a logger. So this is cool. I added the ability in plugins when you author a plugin. If you're building something that interacts with the file system, you can obtain a service.fs from the Benthos plugin APIs, and what that allows you to do is make sure that if Benthos is being run in an environment where that stuff is kind of sandboxed or restricted, you will honor that with your plugin. So I can enforce that with plugins that are built that we distribute with the normal Benthos, but when you're writing your own custom plugins, obviously you can do whatever you want, but if you want to build something that's going to be safer in that world, then you can do this. You can basically opt into using the service.fs that gets provided. See, I like that. Thank you for that. Appreciate that. And then we pull out all the fields. So this is what it looks like when you instantiate your thing, your plugin. When it gets instantiated from a config, you get your conf, and then you get this resources item. This basically just gives you access to all the service-wide resources, and that's where you get your logger, and it's where you get your file system reference thing. We pull out all these fields. This is all fine. Lots of if-ers. But that's just Go, innit? I'm not going to blame you for that, am I? Auth config, yep. Right, so when we connect, we've got a connection mutex, just in case this gets called off a bunch of threads. So this is a pattern that we use in a couple places where we put an error up here, and then if the error is null when we return, that's when we clean up any resources that we might have kicked off. Because you imagine you've got to open a connection, which is something that needs cleaning up, and then you might do something with it, and then do something, and then do something, and you might have multiple resources now that need shutting down, and independently garbage collecting. So it's annoying AF to have to make that explicit all over the place. So rather than do that, if things went wrong, put it in the defer, and we close that stuff if it's there. So here we build up all of the options. We create a Jetstream connection. We access the key value thing for our bucket. That's very clear. We've got some watch options. That's cool. We do a little log message, tell people that it's doing the thing that you told it to do, which is cool. Very clean. We've got a disconnect thing. And again, that just does this stuff here. This. We have a function which is called this, and it does this. Aren't you glad you got me to guide you through this? And then when we do a read, we grab our watcher, hide that within a mutex, but then we don't need the mutex beyond that. If it's nil, that means we're not connected, so we return not connected. That then prompts the thing that's calling read to call connect instead. And then we actually put this in a for loop, so we look for updates, and if our context gets cancelled, we return that. If it's not open, we make sure we've cleaned up all of our existing resources if there are some, and then we return not connected. That's fine. If the entry is nil, continue. So I imagine this is probably fine because this has been built by Jeremy, who works at Synadia. My assumption looking at this would be, oh, what if that's a busy loop? So what if updates is giving us back a nil entry, and we're stuck in some horrible busy loop of chaos and it burns your CPU? I'm assuming that's already accounted for, and that what's actually happening here is there's an internal timeout that might return nil under certain circumstances. So I'm going to trust that this is fine. I could add a comment. Should I add a comment and just clarify that? No. Can't be bothered. I'm sure Jeremy has considered that. I'll add a comment. And then we log that we received a thing. That's a debug log, which is appropriate, I might say. It could be a performance hit here. I really don't think that's going to be significant. I think that's probably fine. And then finally we do a conversion of whatever the entry is into our message format. And this function being returned here, that is scary looking. Anybody looking at this should be scared, because that's an acknowledgement function that does nothing, and that's fine. The reason why that's fine is because Jeremy has wrapped this component type within auto retry next. So if a message gets read from this, gets sent downstream, if it can't be routed anywhere and the config hasn't accounted for that, so the message has just basically just been rejected outright, what will happen is this component here takes care of retrying in a loop and applying back off and all that stuff. So you don't have to do that in your implementation here. You can just give a ACK function that does nothing, because in this context there is no ACK. The update feed doesn't have a concept of these updates needing to be acknowledged. You're basically just reading a pub sub, so it's fine. And then we've got our close function. So when we want to close down this component, this is what gets called here. We disconnect on a go routine, and once that's finished, we call shutdown complete, and then we wait for that shutdown complete signal to have happened, or for the context to get cancelled. This is yummy. This is a pattern that we've got in multiple places, and it works a treat. And then we've got some tests. This is mostly just testing that the config gets parsed out correctly. That's fine, because I'm assuming that there's integration tests. And yes, look, integration KV. Look, Jeremy has done it. Look. Integration KV test. This is yummy. Very yummy looking. We need to make this key random, as the NAT server will only deliver the latest revision of a key when it's requested by a watcher. This is by design, but if we want to test Benthos semantics like batching, we should use unique keys for ever message. Ever message? What do you mean every message? Oh, does that not work? I want it to be both bold and... Does that work? There we go. I am surprised that this... Oh shit, that's lit. Sorry, ignore me, this is really cool. So we don't have to specify key here because the default is everything. That's cool. And then yeah, we can just, he's gone ahead and used all of the typical integration tests. And we've got processor integration tests as well. So we've got a suite of stream tests, and that gets run. And then separately there's a processor integration test. It'll be a bit more involved, unfortunately, because there's not much frameworking within Benthos for doing processor integration tests. You kind of just have to do all that yourself. Whereas for streaming, you can just use our suite to specify a bunch of tests to run. But there you go. So we've got operations. So I haven't actually looked at the implementation of the processor yet, but here we go. So this is the output. So the key is an interpolated string. That means you can pull out information from a message to specify the key, or you can just have a static string. That's good, I like that. Very, very similar. So I'm guessing this is just going to be all in all very, very similar to the input. Which is a good thing, because the input looks very nice, very yummy. Thank you for using try-string here. A minor one, but I see another log entry's KV is uppercase. Perhaps I should recapitalize the consistency. Sure. I'm not going to fail the pull request for something like that, but it would be nice if everything's consistent. But yeah, not gonna fail you for it. Same thing again here with the close logic. Yes, GitHub, I want to look at the file. If I'm reviewing the pull request, I would like to look at what the pull request has within it, please, asshole. So these are all the operations you can perform. Got get, revision, create, put, update, delete, purge, history, keys. That looks like it's pretty much everything that they had listed here, which is cool. That's yummy, yummy, yum, yum. And then this is all the ops here. That's nice and clean. Performance operations on a that's key value bucket. Input. Cool, nicely documented. So here again, we've got URLs, bucket, operation, the key is interpolated, the revision of the key to operate on. Wow, that's pretty wild. That's pretty wild. So you can update a specific revision of a key. What the fuck is that for? Dang, son, that's powerful. And then we've got lint rule. This is very cool. So in Benthos land, you specify all your config fields. So specified all the stuff. We've got examples, we've got defaults, we've got all the bits. That all results in linting rules being essentially made up for your config. So you have to specify things that don't have a default or are marked as optional. All that stuff. So for example here you could not specify this even though it doesn't have a default because optional has been made. So all these linting rules appear and they do all this stuff, but sometimes that ain't enough. So what you can do is you can specify a linting rule, and this is Bloblang, and basically this will just be run dynamically when somebody wants to lint their Benthos config, and it can check. It's much more powerful than what's there by default. So here what he's done is if the operation is either get, revision or update, can we write tests for linting rules? You actually can, because you can write unit tests that parse the config and then check the error that comes back, because there'll be a linting error if it's bad. So yeah, you can write your tests for your linting rules. It's a bit indirect, but then I think it's probably what you want to have happen anyway, because you want to make sure that a config itself is going to trigger your linting rule, and then it comes back as a nice well-formed linting rule. So yeah, you can. I'm not sure I've got any good examples of it anywhere, but you definitely can. Root equals match, get revision. So if this operation is either get revision or update, and the revision doesn't exist, so if the field revision doesn't exist, it's been marked optional, I'm guessing. Yeah, like I just showed you, revision is optional. So if you're one of these and you haven't specified it, then it tells you it must be set when operations blah. That's very cool. If otherwise, if the opposite is true, so well, not the opposite, but if get revision or update are not the operation and you specified revision, then it tells you off for that. You can't set this when it's not needed. If the key is empty, it's not specified, and the operation is not keys, then you get told off for that, which is cool. And if the key, if again, the other case where if you have specified a key and the operation is keys, then it tells you that's not right. That's very cool. So basically, depending on the operation you've got, there's different linting rules. That's pretty much bang on exactly the type of thing that lint rule is specifically for. And then we've got the actual implementation. This is going to be very similar, I'm guessing. Got a KV reference, try string, and then we get. Okay, so we just do a switch on the operation. That's fine. I mean, it looks tidy enough, so that's all good. To do support revision here, so kv delete. Okay, so deleting a specific revision of a thing. Do we specify that is what we do? Because if so, then we need to change something. Okay, deletes the key value pair but keeps historical values. Oh, okay, yeah. So we haven't specified that it's for delete. That's fine. So this basically says if the operation isn't something that we recognize, you're naughty. This is only a fallback, so if you're looking at this thinking, oh, that's not great, because that means Benthos is already running your config by the time you realize the operation's wrong. This is just a fallback in case, well, it would already be caught as a linting error or a config read error if the operator type isn't something that we've specified. So chill out, relax, it's all fine. Parse revision. There's a little helper function there, and then we've got the add metadata bit. We've got the connect. When does that actually get called? Okay, yeah, in the constructor. That makes sense. Yeah, okay, that's fine. Let me close. And then we just got this util function. That's good, that's it. Everything else is the documentation that gets generated with it. Damn. I was kind of hoping to really tear Jeremy a new one, but just a few nits. Okay, Jeremy. Okay. So as Mihai mentioned in the chat, if you are interested in watching Jeremy making this pull request, that's also on the internet from what I understand. I think it's on his Twitch. Unless he took down the VOD, because I think it was there, because I did watch it. So unless it's gone now, you can go and check that out. I think that's it for me today. I'm just gonna consider that a win that my baby didn't wake up. Like this video, for fuck's sake. Subscribe to the channel, please, for the love of God. And stay tuned for the next one. I say this every fucking stream, I'll try and give more heads up before the next one. I probably won't. Just gonna be real. I probably won't. That's not how my life works right now. But yeah, thank you everybody for watching. Hopefully this hasn't been too shit. And you've had a good time. Fuck you, Jeremy. See ya.